Thank you for watching Knowledge Academy. So just so you know, giving you a short introduction about this topic so we can talk about the detail of the topic rather than the background. There is a scientist long time ago, mathematician in France. His name is Lagrange. I mean, he's a French mathematician. So what he discovered is every scenario we have, let's suppose you have, um, you want to study and you have your grades. So you have two parameters, your grades, which is G, and how many hours you study, which is H. Okay, two parameters. If you want higher grades, you have to study more, right? And if you study more, you have a higher grades. If you study less, you have a lower grades. So if I want to create an equation for this situation, and that equation can be representing by a curve, so I can draw a curve right like this. Maybe if you study more, your grades will be higher, right? And if you get to some point, if you study less, your grades will be low, and that creates this one. It depends on the parameters, how many hours you study, how smart you are, and what kind of subject is that. You are really interested on that subject. Maybe this curve is shifting like this. Maybe this curve is like a little bit this, right? Now, since you are studying, definitely you are trading off, right? You are trading off. So if you study a lot, if you study a lot, you maybe try to not to play sports, or maybe you don't have any kind of extra curriculum activity, or maybe you wanna watch movies, but you couldn't watch movie because you study a lot. So you set a target for you. Say, you know what? No matter what, I'm not gonna study more than whatever 16 hours every day, like more than 16 hours every day, and you can draw a line. You say I can study here, I can keep going up and up and up, but I'm not gonna study more than that. So that's my peak, that's my maximum. Okay, that's your maximum. So your new maximum is the red line. But let's put it this way, go back to the topic we discussed in our previous sessions. I talk about maxima and minima. Maxima and minima. Right? And earlier, when you have no constraint, so this is my constraint. This is my constraint. And earlier, my original maximum was the green one. That's my initial maximum. Initial maximum, and that is my new maximum. Right? This is a simple version of this Lagrange. So what I'm going to do, I'm going to say is my old maximum. Old maximum, OM means old maximum, equals to new maximum, and means new maximum. But you're going to put something here, a factor, maybe a factor, right? Or maybe I would say a multiplier. Right? A multiplier. Now the thing is, let's suppose you used to work for, or you supposed to be study 24 hours. Like hypothetical case, you cannot study 24 hours, but just to make 24 hours. Now you set the limit for 16 hours. You're gonna multiply this 24 with something. What is the number should be? It's about 2/3, right? It's about 2/3. So 2/3 you multiply. This guy, what I'm saying here, this is Lagrange multiplier. Make sense? This is a Lagrange multiplier. Now the thing is, I did not mention to you, but there is a point is, this white curve have an equation. This curve, this yellow curve, also have an equation. So every time we have a Lagrange question, you have function, actual function, and then you have another function, which is, maybe I can say gx. So this is my original function. and that is my constraint. Okay, that is your constraint. Now the thing is that this could be 1, this could be 2. I'm going to add another one. If you let's suppose somebody you maybe have a medical limitation. Let's assume, right? I hope nobody have one, but let's suppose you have a medical situation or medical conditions where you cannot even study 16 hours. You says, well, I could study 16 hours and watch movies, but the problem is with this condition, I cannot even study 16 hours. I'm going to study a little bit less. I have another condition here. So that's another curve, right? So I'm going to be making another curve for G. Maybe I can make another curve called HX. And that's my second constraint, right? So second constraint actually bring my maximum further down here. So maybe I can say now I can only study 11 hours because I could study 16 hours if you have no medical problem, but because of these conditions and I have to do some take care of myself, my health, I couldn't even study with 16 hours. I'm going to go study 11 hours. And this thing keep going on and on. As more constraint involved, as more more complicated um, the solution, right? Or you do a lot of work for that. So these are the pretty much what the background of Lagrange. Let's jumping and do some problems. Yeah. In order to do that, when I solve this thing, I don't care about the curve. What I do, I take a I take a gradient. Gradient always a vector. So I'm going to make a vector. So this gradient vector and this gradient vector on the same direction, right? They should be in the same direction because both are moving towards that. So let's suppose you are here. You are here at this point. You start a study a few hours here. Now your goal is you says, well, if I have no constraint, no red color constraint, no yellow color line, no constraint, I'm going to be heading towards here, like tip, like this way. But because of the constraint, I'm also heading towards this way. So if you have two vectors like this vector and another vector, this vector, they might have a different sizes. They might have a different sizes. And these different sizes can be determined by using this gradient. Or maybe this one is F, right? So vector F gradient and vector G gradient, vector H gradient. So really what I'm going to write this vector look like this, F, and then equal to gradient G, and I'm going to put something here called multiplier, which is Lagrange multiplier. And this time I'm going to call them some random variable, and we use lambda. You can use anything to be honest, but standard is just use lambda. Okay. So now take a look on some problems and then try to grab that matters. Usually this topic is not too easy for a student if you don't remember all these background. Okay, so we have a problem. So given f is my function and it is x, y, z equals to 3x squared plus y squared. Remember, this is my original function or my scenario, like I want to study that much. And this is my constraint. Minus 50. Use Lagrange multiplier to find the maximum or minimum values. Remember, these condition can be applied on both maximum or minimum values. So you have a constraint for maximum and you also have a constraint for minimum. Just like you just, sometimes you just get any service, you go to any place and order something, they have a minimum charges. They charge you minimum, right? You call them, they have some charges to serve you. Doesn't matter what you order. So you have a minimum service charges and then plus whatever you want, what kind of service you want. So that is this is my fx, and I can call this is my gx yz. Okay, and this one equals to k, which is minus 50 here. So really we have four variables, x, y, z, and then lambda. We have four variables. So what I'm going to do, I'm going to be making my equation. I'm going to write here equation equals to lambda to g. Okay, this means I'm going to be taking my variable for like this. I'm going to taking fx, fy, fz. These are the three variable, like partial derivative, and this one's going to be gx, gy, gz. I can further elaborate this one and writing like this: fx equals to lambda gx, fy equals to lambda gy, and fg equals to lambda gc. Okay, I have everything. I'm going to take the partial derivative. So fx for this one will be 6x equals to lambda, and the gx will be equals to 3. Okay, here I'm going to be taking fy is equal to 2y equals to lambda, and it's going to be just 2, right? Just 2. And then fz equals to minus 4z equals to lambda, and this one is going to be minus 8. Okay, here x equals to 1 over 2 lambda. I'm going to find the x value. Here y equals to just lambda. They can cancel out. Here z equals to, here's 2, 2, and then minus sign is going to be canceling out. So z equals to 2 lambda. Okay, I got all my three answers, x, y, z, in the form of lambda. I'm going to take this and substitute into equation of g. Like, I'm going to substitute into gx. Okay, and what is that? Is that equal is going to be look like this? It's going to be 3, like this equation. 3x, x equals to half lambda plus 2 lambda plus, so it's going to be minus 8z. So minus 8 and z is 2 lambda plus 2 minus 50. If we solve further, it's going to be look like it's going to be 6 14 lambda minus 16 lambda and equals to minus 50. So if I'm going to be taking the, solve this one, is going to be, I'm going to take here 2, then 3 lambda minus 14 times 28 lambda, and no, I think it's a 16 lambda. So 2 plus 2 and minus 16 will be minus 14 lambda. So I think I'm good here, and then equals to minus 50. If I further solve, this guy is equals to 3 lambda minus 28 lambda equals to minus 100. Okay, If I solve this one further, it's going to be minus 25. So I'm going to just make a line and solving here. So here is 3 and then minus 25 lambda equals to minus 100. And if I divide this lambda here, so lambda equals to 4. Okay, my lambda got 4. I'm going to take if lambda equals to 4, x equals to something. So x equals to here half over lambda. So 4 times half lambda. So maybe I'm going to say 4 times half, y equals to 4, z equals to 8, 4 times 2, 8. I'm going to simplify this one. Is going to be 2, 2. So lambda x equals to 2. So we have a limited space. I'm going to just delete this one and then put just a final value, which is 2. So really these are the values I got when lambda equals to x. So what I'm going to do, if lambda equals to x, my function, which is this function, equals to 2, 4, 8, and then I'm going to be just substituting the values 3, 2 squared plus 4 squared minus 2, 8 squared. If I solve further, it's going to be 4 times 12 plus 16 minus 128. 8 times 8 is 64, times 2 is 128. If I solve further, my answer would be 28 minus 128. The answer is minus 100. Yeah. That is my minimum value when I have this constraint. Okay, this is my minimum value look like when we have this constraint. We can try other values just to check. So you don't have to do it, just for checking. If I'm going to put some other values like x, y, z value, maybe I can say the value of x is 4, minus 3, and 7. Some other values than these x, y, z values. Some other values than this. I'm going to substitute is going to be equal to how do we know it's a minimum? Yeah, so that's what I'm checking right now. Right. So if this is I'm checking, substituting this value 4, minus 3, and 7. And if I substitute, the value is going to be 3, 4 plus minus 3 square minus 2 and 7 square. Make sure you do not pick up on the random values. Maybe they gave you undeterminate value like 0 or something. So I substitute this value. Is going to be 12 plus 9 minus 49 and 2 is going to be 98 something, right? And if you solve this one, maybe the answer is something, maybe something else. So 12 plus 9 is 21. 21 minus 98 is something, not 100. So you're going to get minus value, but it's going to be less than, maybe, it's going to be, 98 minus 21. If you remove 21, it's going to be 80. And then 80 and then 77, I believe. Yeah, so you got 77. So minus 77, you can see here. So that's a lower minimum value. So this is our value. And looking this one, if I do another value, is going to show me another value. So look like this is a minimum. So really, maybe the function is going this way. And this value, right, this one. But if you substitute any other value, maybe you are here. This minus 77 is here. Okay. Now the thing is, I'm drawing this function look like this, but maybe this function being chopped or trimmed because of the constraint. Remember we made this guy originally, but now after this Lagrange, we have some constraint. So I cannot go this way and continue. I have to go here and then that. That's my minus 100 actually. It's going to be look like minus 100 here. If that's a shape. I don't know really the shape is, and I'm not interested to draw these shapes. Okay. Okay. Maybe look at the examples. I have a given xyz function, and the function is giving something which is 4x plus 2y plus 6z and x squared plus y squared plus z squared and equals to 14. Use Lagrange multiplier to find the maximum or minimum value. Okay, I'm just saying you don't have to use Lagrange multiplier. You have other technique. You can solve them manually, but it's going to take much more longer time. Use Lagrange multiplier. Let's start doing that. I write this, just writing the formula. Formula is like this. Make sure you're writing this formula. It's really simple to remember. Okay. And then I'm going to be just jumping into I'm going to split the formula into all three component equals to lambda gx fy lambda gy and fc equals to lambda gz. Now I'm going to take the derivative, a partial derivative. So first one will be fx will be 4 equals to lambda gx will be here is 2x. Fy equals to 2 and lambda, this one is equals to 2y. And z equals to 6 equals to lambda and then equals to 2z. From here, if I'm going to solve x, y, z again, just like we did earlier, x, y, z from there. So x equals to here is 4, 2, so 2 over lambda. So this is our strategy. We always we need to find x, y, z, substitute into the constraint equation because we have a constant here. Remember, this is k. So if you think about it, this k is a k value. Remember the topic we did called level curve. So we have a curve like this, and we chopping this curve into many slices, and we making a circle. Like these slices going to be look like big circle. Then this slice look like smaller circle. Then this slice look like smaller circle, right? So these are the k values. So really, this is the k come from there. But anyway, I'm gonna come here and then y equals 2 to cancel. So y equals to just lambda. No, sorry, 1 over lambda. And here z is gonna be 3. So z equals to 3 over lambda. All right, I'm going to substitute into equation for g, right? Gx I can call x, y, z. And I'm going to substitute there. So x, y, z value is going to be look like 2 over lambda square plus 1 over lambda square plus 3 over lambda square, and everything will be equal to 14. If I'm going to open these squares, it's going to be 4 over lambda square plus 1 over lambda square plus 9 over lambda square equals to 14. If I take if I'm try to solve this, is 1 plus 5 and 9 is going to be 14 over lambda square over 14. From here I say lambda square equals to 14 over 14 is 1, so I'm going to just writing 1. Further, if I want to be doing square root on both sides, so lambda equals to daily plus minus 1. Okay, it means I have two values of lambda, right? I have two values of lambda. So this problem is a little bit tricky, and it gives you both options. The one we were talking about is max or min, or maybe more, both, right? Max or min, or maybe both. So the thing is, I'm going to be doing the way it's going to work is that maybe the function looks like this, and the line is going to be cutting off like this. So you have a max limit here. You want to be going up, but you could not because you restrict here. But if you want to going down, maybe you restrict it here. Maybe the function is going down further, but you cannot go further. So this is your max, new max, and new min, right? New max and new min. But I have a limited space. I'm going to erase that guy. So I'm going to be solving over here. So what I'm going to do, I'm going to say is, what is the x and y and z value if lambda equals to 1 and if lambda equals to minus 1? So if my lambda equals to 1, x equals to here, where is that? We have 1 over lambda, so it's going to be 1. And y equals to, if lambda equals to 1 equals to y, 1 over lambda is going to be 1. So it's going to be 2. X equals to 2 by lambda is going to be 2. And y equals to 1. And z equals to 3 over lambda, so 3 is going to z is going to be equal to 3. These are my new number, right? And if lambda equals to 1, my x equals to, sorry, minus 1, my x equals to minus 2, my y equals to minus 1, and my z equals to minus 3. Okay, I got two values of the function, and I'm going to substitute and finding the possible answer. Okay, so what I'm going to do, I'm going to take this guy and substitute function, right, for lambda equals to 1. I'm going to substitute this value into the function, and it's going to be 1, 2, 1, and 3. 2, 1, and 3. These are the numbers I have it here. So 2, 1, and 3. If I substitute into my function, it's 4, 2 plus 2 minus 1, 1, and plus 6 times 3. So it's going to be 8 plus 2 plus 18. And if you solve everything, the answer would be 28, right? 18 plus 10. It's really simple. I'm going to get this value. I know it's a max value, looks like to me, because positive, but not guaranteed, right? It's not guaranteed. And I don't have to check again in this case, it's going to be, I'm not worrying about if there is any other values on that. So I'm leaving 28. It looks like a positive value. So let's check the other one. So we have complete answer. If lambda equals to minus 1, my function would be, the values are minus 1, minus 2, minus 3, right? Minus 1, minus 2, minus 3. If I substitute that value, it's going to be look like 4 minus 1 plus 2 minus 2 plus 6 minus 3. Okay, this is minus 1, just so you know, minus 1. And if I solve, it's going to be 4 with minus sign, minus 8, minus 18. Solve this thing, everything with 2y. It's going to be 8 minus 2 and 18. Okay. 4 minus 1. Divided sign. This guy should not. So minus 4 and then minus 4 and minus 18. Okay, looks right now. If I substitute these values, it's going to be minus 4, minus 8, and minus 8 and 18 will be minus 26, I believe. That is my other value. So look like this is my max. My max is 28 and my min is minus 26. Okay. So since we are running out of time, I'm going to give you some homework just for practice, right? So if I have a function, if fx and fxy, just two functions, so should have much easier. If fxy is x squared plus y squared, and your constraint, right? I'm using the constraint value, so they should be g and equals to x plus 2y minus 5 equals to 0. Look like this is a plane. Look like this is a function, maybe 2D. This look like maybe a circular function, but this one is a plane. So can you solve this one? And if my function is 3x plus y plus 10, this is a plane, kind of plane, like 2D plane pretty much, and the constraint is, my constraint is x squared y equals to 6. Solve them. You can solve your own and then figure it out what the value you got. You got maximum value, minimum value, and if you get only one value for a function, maybe you substitute a couple of other values up and down. So really what is the point is, when you get a value for a function like this, or you get a value for a function like this, you're going to be taking, let's suppose this point, you solve this, the point, the x and y value you got, 2, 2. And after you substitute into the function like this, x squared for y squared, and the answer is, don't take my numbers, I'm just substituting for example. So it's going to be 2 squared plus 2 squared, you substitute, the answer will be 8, right? Now you want to know this is a maximum or minimum. So what you do, you just substitute another value here and maybe look at 2, 1, 1, right? Look at 2, 1, 1. And then later you may be checking 3, 1. So if you substitute these values, more likely you somewhere here, if this is the shape, you're going to be here, you're going to be here. So definitely you're going to get less value than 8. But if you're substituting other values, it might be going to give you some other answer. So you make sure you are on the curve. You're going to be substituting other values, you're going to give you other answer, and they will give you. But usually when this is in the problems like this is maximize this function. If you say something look like this in the problem, it means they already know that the function is going towards the peak. So you maximizing. So you don't have to check anything, is already going into the max. So whatever value you got chop, you got this value. Remember this is a constraint, and then you substitute the value. Thank you for watching Knowledge Academy. Please subscribe my channel.